Hello everyone. Today we are going to see operating system unit 2 session 15. In the previous topic we have completed the concept round robin scheduling algorithm. So till now we have completed 4 scheduling algorithms. First one is first come first serve, then SGF scheduling algorithm, priority and round robin. So these are the 4 basic scheduling algorithm, and more than one scheduling algorithm can be applied to in the operating system. Now there is another type of scheduling algorithm, that is multi-level queue scheduling. So till now whichever the algorithms we have studied, scheduling algorithms, so in that we have studied that there is only one ready queue for every scheduling algorithm. So whenever the processes come for the execution, so all processes will be put up into the ready queue, and from that ready queue one by one the process will be selected. For example, see, so when the process comes for execution, there is only one ready queue, and all processes are put up into the single ready queue. So using the scheduling algorithm, the processes will be selected from this ready queue and will be given to the CPU for execution. Now this is what this is the working in the previous algorithms. Now in this algorithm, so whenever the process comes for execution, so which type of process it is recognized. So we don't have the same type of processes in real scenarios. If you consider, we don't have the same type of processes because we do different tasks on the operating system. So we need to first recognize what type of process that is. So that this algorithm recognizes that. So whenever the processes comes for execution, so which type of process it is, it will be recognized, and based on that it will be put up into that particular ready queue. That means every type of process is going to have here now different queues. So every type of process is going to have here now different queues. So there is no single queue in this scheduling algorithm. So based on type of process, you are going to have different ready queue. So whenever process comes for execution, which type of process it will be recognized and will be put up into that particular ready queue. So let us see which are those various types of processes. So these are the various types of processes. So when the processes come, it will be recognized which type of process it is and will be put up into the ready queue. So this is ready queue 1, where we have system processes. This is ready queue 2, where we have interactive processes. Ready queue 3, 4 and 5. So different types of processes we have recognized, and process will be put up into this ready queue. So the system processes is considered as the highest priority. So whenever the system processes comes in this queue, then these are the first processes to be executed. So what are the system processes? So system processes are like interruptions, or where you need the operating system to be immediate response. So these processes are considered as system processes. So whenever any interruptions come in the system, that must be handled first, and these are considered as highest priority processes. Then we have interactive processes. So what are these interactive processes? Now interactive processes are where you are directly interacting with the applications, like when you are playing the online games, watching the movies. So when you are playing the online games, there must be the interaction with the game. Then next we have interactive editing processes. So interactive, here also you have the interaction, but where you need the editing. And suppose when you are playing the game where you need to edit some task and all, then those processes will be put up into this. Then batch processes. Batch processes are like you keep it for execution, and it keep on doing its work, and later on you can check it out. So you can submit the lot of processes for execution and leave it, and you can later see the result. So student processes are considered as the lowest priority processes. Student processes are like whenever the student is going to execute any programs, or any other task. So such processes are considered as lowest priority of student processes. Now how the execution of these processes happens? So execution of these processes happens on the different scheduling algorithms. So at each level, different scheduling algorithms can be applied. For system level, all system level processes can be executed using round robin scheduling. Interactive processes can be also executed using round robin scheduling, and editing processes can be executed using SJF scheduling, and batch processes can be executed using priority scheduling, and student processes can be executed using first come first serve based scheduling. So at each level of processes you can apply different algorithms. So all system processes will be executed using round robin scheduling, and batch process will be executed using priority scheduling, and student process will be executed using first come first serve. So in this scheduling algorithm, system processes is considered as higher priority processes. If there are processes in the system processes level, then this process will get executed first. If the system processes are executing, all other execution of processes will be stopped, and first higher priority process will be executed. Now if this system process ready queue is empty, then only the other process level are taken for execution. If this is empty, then interactive process will get executed. Okay, even if the interactive process ready queue is empty, then interactive editing process will get executed. Even if this is empty, then batch process will get the chance for execution, and then later student process will get the chance for execution. So the highest priority process will be placed at the top and will get executed first, and the lowest priority process will be put up into the lowest and will be executed after the high priority process. That is also only after completion of the all high priority process it will get executed. So because of this here, so this algorithm faces the problem, that is starvation. So starvation means where the processes are waiting for a long period of time in the lower priority queue. Now suppose here the processes are waiting. Now suppose the process P1 and P2 are there in the system processes, and process P3 is there in the student process. Now after the execution of process P1 and P2, P3 will get the chance for execution. So after finishing P1 and P2, again another process has come into the queue now. Now here process P4 has come in the interactive process. Then the chance will be given to process P4, and P3 has to keep on waiting here because it has lowest priority. So here the problem is that the lowest priority processes keeps on waiting here. So if the higher priority process keeps on coming, the lower priority process will never get the chance for execution and they suffer from starvation. So if for this algorithm, we don't get any problem to solve, just a theory question can be asked on this multi-level queue scheduling. So multi-level queue, that is ready queue, is partitioned into separate queues, foreground and background. So foreground processes are mostly the higher priority processes and background processes are the lower priority processes. Processes are permanently in a given queue. Each queue has its own scheduling algorithm. For foreground processes, you can have different algorithms. For background processes, you can have different algorithms. Scheduling must be done between the queues. Fixed priority scheduling and time slice. So if it is a round robin scheduling, then each queue gets a certain amount of CPU time which can be scheduled among its processes. That is 80% to foreground in round robin, 20% to background in first come first serve. So different algorithms can be applied to foreground processes, higher priority processes, and background processes, lower priority processes. Next algorithm we'll see multi-level feedback queue algorithm. In the previous algorithm, multi-level queue, we have seen that there is a starvation problem. So the lower priority processes face the starvation problem. If the higher priority process keeps on coming, the lower priority processes may not get the chance to execute and they have to keep on waiting. So to solve that problem, multi-level feedback queue algorithm is there. So in this algorithm, what happens? The lower priority process starvation problem will be solved by the technique, aging technique. So when the low priority processes comes in the lower priority, then such processes will wait for some time. If they don't get the chance to execute, then automatically its priority will be increased level by level. Then when that process increases at the top level, that is at the highest priority levels, then automatically that process will get executed. So like this way that problem will be solved. See, this is how the time will be assigned in various levels. So if you are using round robin algorithm, so at various level different times will be assigned. So how the processes comes to the from lower priority to the higher priority, it will get executed. See, for example, the process has come with unit 10. The process P1 has come with unit 10. So it needs total time 10 units to execute. So this process comes in the lowest priority. This process comes in the lowest priority and this is highest priority. So when the process comes in the lowest priority, it is going to execute for 2 units. So out of 10 units, it is going to execute 2 units. So the remaining 8 units have to be executed. So then the process P1 will be moved up to higher level. Now the process P1 comes here and now it has to execute 8 units. So out of 8 units, now here the time slice is 4. Now in this level, the time slice given for each process to execute is 4 units. So it is going to execute 4 units out of 8. So still 4 units has to be executed. Next, again that process will be moved to the next level. Now in this level, the time given is 8 units. Now the process P1 has to execute for 4 units. So this process will get executed at this level. So like this way, the starvation problem will be solved by aging technique by increasing the priority of the processes level by level. So level by level, the priority will be increased and when it reaches at the higher level, it will get executed. They are given the problem. Consider a system which has CPU bound process which requires burst time of 40 time units. So one process has come with 40 units. Then apply multi-level queue scheduling. Then the time given is 2 units. So at the lowest level, the time given is 2 units and it will be incremented by 5 units in each level. So the lowest level, the time given is 2 units and step by step, level by level, it increases by 5 units. So how many times the process will be interrupted and in which queue the process will complete the execution. And this is how the levels are connected. So at the lowest level, the time given is 2 units. And then level by level, it has to increment by 5 units. So when you increment by 5, it is going to be 7. Again, when you increment by 5, it is going to be 12. Again, when you increment by 5, it is 17. And again, when you increment by 5, it is 22. So like this way, when the process comes in the lowest priority, then first it will execute first 2 units. So total 40 units are given for the process. So out of 40 at the lowest level, it is going to execute 2 units. So 38 units are remaining. Now after some time, it will be moved up to next level. Now in the next level, the time given is 7 units. So 7 it is going to execute. So total remaining units are 31. Similarly, in the next level, the time given is 12. In the next unit is going to be 19 after execution. And then next it is going to be 2 units. Still 2 units has to execute, and when it come to the top level, here it will get executed. So this process with 40 units will get executed at 5th level, and 5 times it is interrupted. So this is how we are going to solve this problem if they give in the exam. Just you need to show these levels and how much times are assigned, and at which level the process will get executed. So here we have finished all scheduling algorithms. Thank you.